Hello, sixth graders. This is Mr. Humphreys. This is the beginning of a new chapter. We are in chapter 7, and that's going to be out of the blue book. So chapter 7 is out of the blue book, which is the 8th grade book. We're going to talk about real numbers and the Pythagorean theorem. In section 7.1, we're going to start talking about finding square roots. Now, before we begin, I want you to write down these two shapes. Draw a square and a circle. I want you to label the top of the square as the area as being 324 squared centimeters. And I want you to write down the area of the circle as 36 pi squared inches. Now let's go back to the square. I want you to use a square root symbol to write the side length of the square. Then find the square root. So I want you to find the length of each side of the square. So what times itself gives you 324? Well, to figure that out, you can take the square root of 324, which gives you 18. That would make each of the sides of the square 18 centimeters. What about the area? The area of the circle is 36 pi squared inches. I want you to find the radius of the circle. Pause the video and try to do that yourself. Find the radius of that circle. Well, what you could do, which I'm hoping you do, is realize that the area of a circle is pi r squared. So if I plug in the area is 36 pi, and then that's going to equal pi r squared because I want to find the value of r. Well, you have to isolate the r squared, so the opposite of times pi, we have to divide both sides by pi. They cancel. So 36 equals r to the second power. What number to the second power gives you 36? It's 6. So we know the radius of the circle would be 6 inches. Now, how did I get 6? I took the square root of both sides of that equation. So that's what we're talking about today, are the square roots of something. So we're going to define two vocab words, square root and perfect square. A square root of a number is a number that when multiplied by itself equals the given number. Now this is something that's a little different that I know you probably have not done. Every positive number has a positive and negative square root. A perfect square is a number with integers as its squared roots. So, to show you an example of what a perfect square is, if you take the square root of, for example, 20, the square root of 20 actually gives you decimals. So it would not be a perfect square because a perfect square gives you integers as its square roots. So if I took the square root of 25, my square root value of 25 is 5. That's an integer. So we're going to start talking a little bit more, though, about what happens when you get a negative once you take the square root of something. So here we have the first example. Find 2 square roots of 49. So a lot of people think, okay, if I take the square root of 49, that's going to give me 7, which is only partially true. If it's asking for 2 square roots, 7 is not the only number times itself that gives you 49. Do you know what the other is? Negative 7 also works. Negative 7 squared gives you 49. So 7 times 7 is 49. Negative 7 times negative 7 is 49. Both values are square roots of 49. Now this chart is on page 290 in the 8th grade book, but it's also something you can write down in your notes if you wanted to. Right off the bat, it starts talking about 2 more vocab words. The square root symbol is actually called the radical sign. It is used to represent a square root. The number under the radical sign is called the radicand. So, this first one you've probably done before, the second two you probably have not. If you just have a squared root, it's asking for a positive square root value. So the square root of 16 is 4. If you have a negative square root, like a negative on the outside of a square root, your answer is going to be negative 4. So negative square root of 16 gives you negative 4. Both square roots look something like this. Plus, we call that plus or minus the square root of 16. So plus or minus. So if you have a plus or minus, that means your answer is plus or minus 4. That means both 4 and negative 4 are your answers. Example number 2, find the square roots. In A, we have the square root of 25. Since that's positive, as you can see up here from our chart, my answer is 5. Part B, negative square root of 9/16. Well, when you do these problems, you take the square root of both the numerator and the denominator. So the square root of 9 is 3. The square root of 16 is 4. It's going to be negative, however, but since the negative is on the outside, it's a negative square root. So that gives you negative 3/4. And then C says plus or minus. Plus or minus the square root of 2.25. Since it's plus or minus, our answer will also be plus or minus. The square root of 2.25 gives you 1.5. So my answer will be plus or minus 1.5. Once again, what that means is that 1.5 and negative 1.5 are my answers. Now you can have either one of these. You can either put a plus or minus in front, or you can write it out separately as two different answers. Squaring a positive number and finding a square root are inverse operations. You can use that relationship to evaluate expressions. So, if I had this, I'm just going to show this to you right now. If I had 5 squared, what's 5 squared? You're right, it's 25. What's the square root of 25? It's 5. Squaring something, taking it to the second power, and taking square root of something are both inverse operations of each other. So those are going to be inverse operations. So you just keep that in the back of your mind. So let's go to example A. 5 times the square root of 36 plus 7. You're going to follow order of operations. 5 times the square root of 36 plus 7, where you're going to multiply first. However, you can simplify the square root of 36. The square root of 36 is just 6 plus 7. So 5 times 6 is 30 plus 7 gives us an answer of 37. B, 1/4 plus the square root of 18 halves. What do you think you're going to do first? I'm hoping you realize that you can take 18 divided by 2. 18 divided by 2 is 9. The square root of 9 is 3. So 1/4 plus 3 gives me the answer of 3 1/4. And lastly, and this is important. Of all the problems, this is a key concept. In this problem, the square root of 81 squared minus 5. I'm going to tell you right now there's a shortcut here. You're probably not going to realize this until you do a few of these. But if we start by taking, inside the parentheses, order of operations, the square root of 81. The square root of 81 is 9. And I'm going to square it minus 5. 9 squared is 81. Well, what do you notice? It's the same thing as what you started with. You started with the square root of 81, and 81 was the number. So this is a key concept. I mean, this is something you have to know. Squaring something and square rooting it are completely opposites, as like our addition and subtraction, multiplication and division. They cancel each other out. So if you see the square root of something that's being squared, you can just take the 81 and bring it right on down. So now you take 81 minus 5, and that will give me an answer of 76. Our last example is example number 4. Example number 4 says, the area of a crop circle is 45,216 square feet. What is the radius of the crop circle? Use 3.14 for pi. So we're going to start with the fact that we know that we're dealing with area of a crop circle. Well, that's the area of a circle. Step 1, write down the formula for area of a circle. The next step is to substitute in the values that we know. So since this is an equation, we have three things here. We have an A, which is area, pi, which is 3.14, and R, which stands for the radius. Well, we know the area. The area is 45,216. So we're going to plug that in right here. 45,216 equals, now we know pi. Pi is 3.14. And the radius we do not know, so it's going to be radius squared. So now we divide both sides by 3.14. As how we solve equations, we do inverse operations. The opposite of times 3.14 is divide by 3.14. That would give us 14,400 equals the radius squared. So now I have to undo the squared. To undo the squared, I take the positive squared root, the positive square root of both sides. The opposite of squaring something is the square root. So just like we did in the last example, right here, the square and the square root cancel each other out. All of this is gone. So then I'm left with R. And what is the square root of 14,400? It would be 120. 120 squared gives you 14,400. So the radius of the crop circle is about 120 feet. So my answer would be 120 feet.